All right. So this second the last use case, this is from, I was at Enzinoc. I met an Italian ISP who had actually built a SDN network. They have converted their whole network into a SDN capable one. I got their permission to share this with you guys. So it's Iolo ISP in Italy, northern Italy, central and northern Italy. They have what's called the Blue Project, right? So they were presenting at Enzinoc. So this is what they did. Without going so much into details, I will give you their contact details. Please contact them yourself directly if you want to know more about how they did it. They built their own router using TileGX, right? Their own router OS. They call it Blue OS. It's based on 6-win gates. And they built their own controller. So they had problems. Initially, they used Openflow for MPLS label switching. But they had a problem because Openflow's granularity problem where every time they needed to change a flow, they needed to program each and every node on the path, push the flows down. So that was their first attempt at trying to implement this in their network. It was a major problem for them. So in the second phase, what they did was, so after about 6 or 7 months, I think now they are using segment routing instead of Openflow. Like I mentioned when we started off, segment routing, but they're using MPLS as the data plane, not V6 as the data plane for segment routing. They have, I think half of Central Italy and then North Italy, they have deployed this network. And it's actually working network. So I thought maybe I'll share you their contact so that instead of too much talk, I think it'd be really nice to talk to people who have actually built it, done it, so that, and they are more than happy if you want to join their project also. So I discussed with them. So here is the email address for them. It's blue@eolo.it. So please feel free to talk to them. It's a really, I have their slides with me. Maybe I'll upload it to the Apricot site with their permission if you want to go through how they went about doing it. But the major learning factor for them was with Openflow, they couldn't really achieve what they wanted to achieve. It was becoming quite tedious to maintain. So they changed from Openflow to segment routing. They also use BGP-LS for topology discovery so that their controller learns about the network topology. So I think this is a really good practical use case where people have done it. Right? So I thought I'll just share it here with you guys. Well, that's about it on the talk itself. We have few simple demos. I was trying to do a packet capture of the open daylight controller trying to manipulate or push flows down into a OV switch. But on the same device, I was having problems. So what we have done is with my colleague, I have run ODL on her PC, her laptop, and then I was running the switch here, and we have captured packets. I have those already with me, so I'll show those. So we will do a very quick, simple demo, basically using Open Daylight Controller and Mininet. The topology is pretty straightforward. It's very simple. Mininet comes with its own default controller for you to just play with. So the first topology, we will do it using Mininet's default controller and see. But that's on the same machine. So we will see how to push a few flows there and how it behaves. And then we will use Openflow version 1.3 with Open Daylight Controller to push some flows into the switch remotely. Okay. Yeah, this will be the first topology we will try to do, and this will be the second topology where we have a separate controller trying to push flows down into the switch. And if we finish this early, we will have enough time for Q&A. That's what I was discussing with Paresh Bhai, that if you have questions, keep it to yourself. Someone asked us a question during the break. We have even saved that question so that it can be answered together. So we will have about 30 to 40 minutes for Q&A purpose, which is good, I think. Right. So let me try and I don't know. Maybe I'll split it out. Do you want the font to be a bit bigger, or is that okay? You can see it. Ah, okay. So Mininet's default topology actually uses their own controller, right? So in our case, I'm not going to use their. In the first example, let's not use their controller. We'll just try and build a simple network, right? And for controller, let's say we don't want a controller. This is just to simplify the MAC addresses that the host might get. If not, it becomes quite difficult to read the MAC addresses. And then we. So right now, what we have done is a very simple topology. If you look at, let me see if I have the slide for you guys where I have also made the topology here in the slide just to simplify things. So right now with that command, what we did was we ended up making a topology, something that looks like this. You have one virtual switch, you have two host machines, and they're connected to the switch, right, without the controller at the moment. Okay. So you can actually look at nodes that are there, right? The available nodes are those. How does the topology or the links look like? So host 1 is connected to switch port 1 on host 2 is connected to switch port 2. Very simple topology, right? And any information about them. So all detailed information about them. And if you, that command really helps the MAC command because it simplifies the MAC address quite a bit. So the host 1 has a MAC address of 1 and host 2 has a MAC address of 2, just for demo purpose, right? Trying to see all the flows that are there on the switch. At the moment, no flows, right? And try and ping the hosts. Let's try and ping host 1 to host 2. Doesn't happen. So I guess this is a problem when you try and extract control plane away from the device. The device is dumb. It really doesn't know what to do when packets come in without somebody telling it what to do, right? So it's a good demo, I suppose. So that's without a controller right now. The switch really doesn't know what to do. So instead, if we try and build a similar topology, but with the controller, using the default controller that is there in Mininet, so now we have at least one controller, right? We have a controller, we have two nodes, and we have a switch. Just adding the controller to it, right? Because when we tried to ping that time, couldn't ping. We looked at the flows, the switch has no flows. So every time a packet comes in, the switch basically doesn't have an idea what to do, right? So right now what we have is a very simple topology. The topology looks something like this, right? We have a controller, we have the same topology we had earlier. Now all we are doing is adding a controller so that we can tell the switch what to do, right? So now with this, network-wise and flow-wise, what do we have? I think flow-wise, at the moment, there shouldn't be any flow, right? Still no flows. The flow needs to be pushed. So if we try and ping, let's ping the other way, H2 ping, right? Now the ping works. We'll try and ping the other way. It works. So if we look at the flows, now you see that there are lots of flows there, right? So initially, without the controller, we saw that the switch had no flows in its flow table, right? Now that we have a controller, there is a flow. Right? We will look into details. I have taken these things out, put it in a slide, easy to read. We will look at how those things work. But for a quick review, you can see that a cookie is nothing but, with Openflow, the controllers need to keep track of what operations they are performing, so it's just an indexing value for the controller itself. You have the idle timeouts for the flow entries. If there is no match for a particular flow, when do you time it out so that you don't need to maintain massive states of flow entries out there, right? What else? So right now what we saw is even though the switch did not know what to do, the switch actually sent the packet up to the controller, and controllers actually started pushing down flows, telling it, if you receive a packet from this port, send it out that port, right? First one, you see there are ARP packets here. ARP. What else? You have ICMP. This is reply. So you have ICMP reply to ICMP request, right? The type is 8, which is a request, and then you have the reply there. And you see the action is, so this is a flow that was inserted by the controller down to the switch. If you receive it on input 1, send it out port 2. So that's an example of a very simple flow, right? If you receive anything on this port, send it out that port. And the match conditions are, if it's a ICMP packet of this type, send it out that way, coming from, we were trying to ping H2 to H1, right, that time, so H2 has a MAC address of 2, H1 has a MAC address of 1, right? So anything coming from this source to this destination with this source IP and this destination IP, the action is, based on those matches, the action is send it out that port. Right? So it gives you a fair idea of what flows look like in Openflow, right? Now, I have tried to take a snapshot of those things and put it in a slide here, right? We saw those, no flows, and now all of a sudden, because the controller can push flows down into the switch can actually forward packets, right? So we have tried to make it as simple as possible, right? Simplifying the flow table. So you saw that I've tried to group it because it wasn't so readable out there. So you see the ARP packets out there first, the ARP request and the ARP replies, right? And then below that is your echo request and the echo replies, right? So it gives you a fair idea about how it works. But it also tells you that the device is dumb, right? A switch is dumb unless the controller tells it what to do. So do we want that level of abstraction? I'm not so sure, because the controller will take time to push down those flows, right? I don't want so I think bootstrapping certain flows ever since Openflow version 1.2 or 1.3, I think there are certain flows that are bootstrapped with the switch, right? So you saw the first ones are the ARP packets from H1 to H2, right? And that one is a ARP reply to the ARP request that was sent, and then you have your ICMP request and ICMP replies. And so it's matching against these things, and the action is send it out this port. If it comes through port 1, send it to port 2. If it comes through port 2, send it out to port 1. Right? Gives you an idea about the flows. So that is that. And if you actually look at the switch itself, the flows actually time out Right now, no flows because they timed out, right? Because if you look at the idle timeout is set to 60 seconds. So it's that way you don't have to maintain that many flows in a table. Right? Well, we could, but right now what we are seeing are the actual flow entries. We are not seeing any of the open flow messages. So what we could do is we could try and snoop so that we can listen to, we can also see open flow messages that are exchanged between the switch supports open flow, the controller talks open flow. So what are the messages that are exchanged between the two of them? Right? So we could snoop, and probably better to do it at the background, right? So it's now snooping. So now if I try and even without that, if I do some flows, so you see the open flow messages that are being exchanged between the switch and the device itself out there. And if I now try and ping the devices, right? So those are the actual open flow messages out there. I look at packet in. So packet in is an open flow message where any message from the switch to the controller comes encapsulated in a packet in message to the controller. The direction is based on the controller. In is inbound to the controller, out is out from the controller, right? So the first packet got encapsulated inside a packet in message. It got sent to the controller, the default controller that it uses, because the switch really doesn't know what to do when it received a ping packet, so it needs to send it to the controller so that controller can tell it what to do. So packet in came, packet out, the instruction is action flooded out all ports. It says if you receive it in port 1. So based on the packet in message, now the controller is actually pushing a packet out message, so into a message to the switch. And your flow mod messages are what actually inserts a flow entry into the flow table on the switch itself, right? Gives a priority. This priority is if there are lots of flow entries, prioritize based on the priority and match against that flow. So the flow mod message says ICMP packets, if it comes on port 2, send it out port 1. So that's the flow instruction that's being pushed by the controller to the switch, and now the switch can actually start sending packets, right? So this gives you a fair idea about how the switch reacts when it receives a packet, doesn't have a flow, doesn't know what to do, sends it up to the controller. Controller looks at the header fields, and then based on that, the controller tells the switch, all right, for this kind of things, do it this way, and it defines the action on how it should do that. Right? And for the second ping, it again pushes the flow entry, right, from H2 to H1. If the inbound port, if you receive a packet on port 1, the action is send it out on port 2 for ICMP packet. So you have pushed 2 flow entries down to the switch now, right? The switch and the controller pretty much exchanges this periodic hellos out there, because that's how they actually negotiate the protocol version that they both support, right? The switch tells the controller that this is the OpenFlow version. The problem with OpenFlow is the versions are not compatible, right? They have a different wire number all the time. Version 1.0 is not compatible with 1.1. So that's why the switch needs to inform the controller that these are the OpenFlow versions that I support, and the controller also lets the switch know what it supports, and they pick the highest common one that they both support, and they talk over that. Right. So yeah, so we saw the flows out there. So that's a very simple demo. I know it might be quite boring for you guys, but it gives you a fair idea about how it works, right? The concept, how it works. So this one is using the default controller that is built into the Mininet toolset, right? We could. The second one, let's do. I'm running two I'm running two VMs here. One is running Mininet, one is running the Open Daylight controller, okay? And here is the let me merge both the windows once. Let me get it up and running. Let's try and fit them together. Still doesn't fit so much. So let's exit out of this, right? And what we will now do is let's try and. So this one is 151, I suppose. Yeah, it's 151, right? So what we will try is, when we initially build this topology, we build it using the default controller here. Let's point this to the remote controller now, right? And I'll pull this just to save myself some time. We could do, let me type it on this file, and I'll directly copy paste the command from the text. That way it's much easier. So what we did right now is, again, simplify the Mac. Now controller, a remote controller. This is 151, the controller, ODL controller that's sitting there. 151, port number 6633, which is the standard 6653 now, I think. But this, most of the controllers still seem to use the old first port numbers. We'll use the same default switch, and we'll use Openflow 1.3. Since 1.2, Openflow became quite extensible. Instead of having rigid static fields, they have this concept of OXM fields, which are extensible using TLVs. So if you look at the network now, you have a controller which is remote, and if you want to look at all their information, so you have the host 1, yeah, host 2, 10.2, we have the default switch that is there, and we have a remote controller, right, 151, talking on this port, right? So here is the controller. And I'll open a browser just to, because we should be able to monitor we should be able to look at the topology from the controllers, from the controller. Start the controller. Takes a while. right, we have the controller now, right? So once we have the controller up and running, I'll try and get, so right now the controller sees only the switch. That's how the controller, this is about topology discovery, right? How the controller, right now since the switch is talking to the controller, it sees the switch. If I exit out of this topology, this will disappear, right? Let me just exit out. So there is nothing, right? When it is not connected to the controller. So there you go. So it detects that. So what we can now do is, let me do EBCTR. Right. Protocol could be your Openflow 1.3. So after version 1.3, there are some flows that are pushed by default. There are flows that are pushed by default by the controller. Okay. It's already there. So that means switch does not necessarily have to wait for the first packet to come in, send that up to the controller, and wait for the controller to. So you have. I'll just try to make this look a bit better. This one, something that matches everything and then drops. So it's a match-all, it's a catch-all entry. This is your table miss entry. If there are, this entry actually says, if a packet comes in and if it does not match any of the entries I have in my flow table, just drop it. So it's called the table miss entry, right? And then you see that for topology discovery, Openflow by default uses LLDP, right? For link layer discovery protocol. So the way it works is, the controller pushes a flow into every switch saying that if the ether type is LLDP, if it's an LLDP packet, send it to me. So that's how it actually discovers how your network is connected in Openflow, right? So you have a LLDP packet here. So it says if the ether type is LLDP, just push it up to the controller, right? And it by default has, based on what it saw on the switch, it actually has two flow entries already sitting there, right? It says if the input port is 1, send it out output port 2. If the input port is 2, the action says output it to port 1, right? So it has already pushed those flows proactively onto the switch. So if we try and Shane, I may not use the mic sometimes. Let's just get that and then try and have a look at the flows. You have two new flows here, right? Action output to port number, anything coming on port, anything coming from this particular source to this particular destination, send it out on port 2. Anything coming from this particular source to this particular destination, send it out on port number 1. So that's how it inserts those flows, right? And if you actually look at the topology by now, so initially we only saw the switch. Now we see. So that's how topology discovery works, right? From an Openflow perspective. So it's a very simple demonstration of trying, and at least it makes it easy to understand how the protocol works, right? So I have tried to break it down because ideally I would like to capture Wireshark packets between the ODL controller and the switch. But on the same device it was difficult, so we have pre-captured that device using my colleague's laptop. And where is it? So I've tried to put them into a slide so that it's readable. So you can filter the display, right? Specifying Openflow version 4. This is the topology we had. So we tried to build that. We tried to build this network, right, with a remote controller from the switch, right? We check the flows. These are proactively pushed by the controller to the switch, right? The last one does not even have a timeout because it's a table miss entry, right? Whereas others have a timeout. There you go. I already discussed this. It's LLDP packets, flow miss entry, drop all packets, right? And this was the. So this I think is more interesting because this is the message exchange between the switch and the controller. So you see that there are periodic hellos being exchanged between the switch and the controller, right? And since we're, I think 1.2 or 1.3, initially it used to be the highest version I support, I send to you, you send me the highest version you support. Sometimes we can't even talk because these versions are not backwards compatible. But with Openflow version 1.3, they have come up with the concept of bitmap, version bitmap, where I list all the versions I support, you list all the versions you support, and we pick the most common one that we support, right? So that's in the version negotiation, the first message, right? And of course, the controller needs to know what the switch supports, so it sends out feature request messages. The switch replies with the features reply message back to the controller, right? And this is the multi-part. This is more to do with stats query from the controller down to the switch. And this is a packet out message. So packet out message is a message from the controller down to the switch encapsulated inside this packet out message. So it's basically, that's how the switch actually, the controller actually does topology discovery by pushing down LLDP entries, flow entries into the switch. It says, if there is a LLDP packet, send it to me, send it to me. So that's what it's doing, right? LLDP, if it comes from this, just send it to the controller, the output action. Flow modification message, so it's pushing down flow entry messages for LLDP, and the output you will see is output is to be sent to the controller himself. You send it to the controller, any LLDP packet, right? What else is there to be seen here? They have tried to make Openflow extensible since version 1.3. So there is this concept of, they make it extensible using TLVs, but there is also this concept of match classes. Instead of matching against certain fields, you can define classes, and you can have multiple fields under those classes. And there is a default class called the Openflow basic class, right? And this includes all the typical packet headers that we use. So they are all put under one basic class. You can actually define your own match fields as different classes and then match according to that. This shows extensibility, right? And it's pushing down the packet out message. Periodically, it depends. Open Daylight, it is sending out LLDP packets every 5 seconds to the switch, right? We can ping it. We looked at the flows. Cookies we already know, right? And that was the. So it's a very simple demo. Sorry if you guys feel bored, but I was trying to make it a bit simpler. So this is the packet that comes from the switch to the controller, encapsulated inside a packet in message, right? With the details of that packet. The second packet in message for the echo request that came in again. So every packet that it receives, the switch may not necessarily send the whole packet to the controller. It might buffer the packet somewhere and only send certain header fields up to the controller to ask what I should do based on this fields. So for that purpose, there are buffer IDs that the controller. So every time I send a message, me as a switch sending a message to the controller, I need to give it a buffer ID too, so that the controller knows that I have buffered the packet, the actual payload. Maybe I'm just sending him the header fields. Right. So you'll find buffer IDs being used. It's quite interesting, actually, Openflow. So from my side, that's it. But like I mentioned, during the break, someone was trying to ask questions. Maybe now might be a good idea, and I had requested Paresh Bhai to be specifically here so that he can take questions. Yes, sir. Yes. So yeah. Yes, there are switches that support Openflow protocol, right? So even in APNIC Lab, we are getting around 6 bare metal switches that we plan to run, and then we will run Openflow over that to test. Access of what environment? My lab environment? I'm not going to give you my lab environment, right? No, I'm just kidding. But you could also get your own switch, right? That supports Openflow. There are some cheap bare metal switches. Open Daylight is open source, right? It's free. Yeah, yeah, I understand. I understand. Yeah. Cheap. Any bare metal switch cheap recommendations, Paresh bhai? P8s or? Yeah. Yeah. You can definitely get bare metal switches out there on which you can run Openflow, and for you to play, you can play. Uh, but if you want me to give you access to the ones that we are trying to build, let's talk offline, you and me. All right? Then everybody asks for that access, right? Yeah, yeah, yeah. Yeah, but again, in the end, I think it boils down to, for me, especially, does it solve a problem, right? If I have a problem and if I can't solve them with my conventional tools, then only maybe I'll look at this, right? If it, I can solve it with my existing tools, I think I'll stick to it for a while. So look at the problem, and if the problem requires this kind of feature sets, like you saw the use case scenario, right? Using conventional tools, that ISP was having so much problem, 48 hours of monitoring. By the time they could react, the traffic pattern has changed, the traffic flow has changed. So it was a real critical problem, so they had to come up with something, right? So if there is a problem that existing tools cannot solve or having problem difficulty to solve, then maybe you could start exploring and saying, okay, I might want to use this for this, right? But from a performance or stress testing things, you could get yourself a switch and start playing with it. Yeah, I really don't know much to say. So yeah, that's about it. Very simple demo, not much, but gives you a fair idea about how the protocol itself works, right? And as you saw in that use case, they were steering traffic actually using Openflow to push down flows to steer your traffic within your own AS on from one LSP to the next LSP. So it gives you a fair idea about how it is done. So with that, Paresh bhai, I think I'm good here. Are we open to taking questions if people have it? So if you guys have questions, please feel free. We have lots of time. We can take questions here. Any questions from anyone? Awal.
Hi, I'm Safi from Equinix. So based on the experience, so we have a lot of controllers in the market, right? For example, Ansible, Taylor, NCS, even they have a open controller, so one proprietary controller. So everyone using different protocols, Openflow or netconf, Ansible using SSH, Taylor using netconf, so Control using netconf. So based on your experience, which is the best one to pick up? So what's the first step to kick into the SDN world? Because I think so many people doesn't know so how to start to kick off.
Yeah, look, I mean, I will not be giving recommendations on commercial controllers here, right, in this audience. Not the right thing to do. But what I would suggest is start with one of the open source ones, like ODL, Open Daylight, right? Just to basically play with it without having to pay for it, right? And there are pros and cons for different controllers, right? So there are reasons why you would go open source, and there are reasons why you would go commercial, and that's a determination you have to make yourself, right? And once you start playing with it, it'll be quite apparent as to which way you need to go in order to get a carrier class solution in your network, right? So I'd say start off with some open source tools. In terms of the protocols themselves, I think we're getting to a point where there is, the industry is converging, right? So when it comes to provisioning network devices, then netconf is netconf Yang, right? Netconf as a protocol and Yang as a data model is becoming pretty much a de facto standard for it. And you find that no matter which commercial solution you pick or which open solution, you go ODL, ONOS, or whatever, they all kind of support similar protocols. There are different stages of maturity, of course, right? All of them, but they're converging in terms of the protocol supported. And it's not a single protocol, right? So in terms of southbound protocols, you have BGPLS for discovery, PCP for path computation, netconf Yang for provisioning and so on. So I'm not sure if that answers your question, but you've got to start from somewhere. So I'd say start with something that does not cost you.
Yeah. Thank you.
Okay. Any other questions? Does everyone have a bit of an understanding of SDN now, at least from the perspective of getting some definition around what SDN is? Yes? No.
Yeah.
Is that a yes? Does that mean yes?
Yes.
Yeah. Can someone come and give us a summary? I'm kidding. How do you? So let me ask some questions, right? Based on what you've heard here, it's a very it's a complex subject, and trying to cover it in 90 minutes or 3 hours actually is pretty difficult. APNIC runs a full 5-day workshop on this if you're interested in attending that at some point. So we had to necessarily, speed up here. So you may not get all the details about how things work. But what I would like to understand, if someone is willing to speak up, is do you see an application for this in your network today? You do? Yep.
Yeah, we have our own application, in-house application to provisioning using Sdn controller.
Right.
Yeah, but the controller we are using an NCS tail-off.
Okay.
Yeah, so using the NCS tail-off, we are using the provisioning for customers. Yeah.
Right. Okay. So just for the benefit of everyone else, we're talking about using SDN for provisioning. So automation of provisioning, right? Basically.
Yeah, that's right. Yeah.
So getting away. So what are you using as the southbound protocol between the controller and the nodes?
Okay, the node we are using different vendors like Juniper, Arista.
Sure.
But the controller we are using Taylor. So we're using the netconf.
Mm-hmm.
So also we are using a Young model, a JSON model
sure.
to push in the configuration based on the services and modules.
Sure.
So which services customer they have to have a BGP or MPLS or those kind of services.
Right.
Yeah.
So that's a pretty common use case, right? So essentially what obviously you're trying to do is abstract the complexity of the different implementations, the different vendors, right? So having a northbound interface that is common regardless of what's underneath, right? And using your tail-off system to actually basically mediate between the different devices.
Because the complex part in SDN, because most of the network engineer, we are not very aware of the programming background.
Right. Sure.
So we need our own developing team to have such promising system
Sure.
to have a provisioning level.
Right.
Yeah. I think that's why most of the network engineers are struggling to learn the SDN.
Sure.
Even they know using the mininet to try out the SDN in order to go for the production. So how they can develop their own programming language.
Absolutely.
Because they are using a JSON or Young model, even they're using the Python module to have some templates to configure,
Sure.
to pushing down the configuration to southbound.
Right.
Yeah.
Okay.
So
Thank you.
do you have any comments on is it really network engineers to know programming language to kick into the
I think it's going to be unavoidable, right?
Yeah.
They're going to need to have some sort of programming. I mean, this is not writing C code, right, or C++. We're talking about, it's more kind of scripting than it is low-level programming. But engineers will have to, today's network engineers will have to pick up that skill, because automation is going to be all about IT systems, right? So you'll have to have that. And if you are a network engineer, then you're probably it's much easier for a network engineer to pick that up than for an IT person to become network aware and an expert in the network side of things. So but yeah, you've got to add more strings to your bow here to succeed in this SDN environment. Anyone else? Any other applications that you see? Any serious problems that you'd like to solve using SDN? Looks like your networks are running pretty smoothly, so
easy to roll back.
Yeah, easy to roll back. Yes. If you give us a second, because we are streaming this as well, so we need
for the benefit
online audience to hear it. That's okay. We don't need to see your face. Yeah.
I already think that many networks are trying to play catch up and trying to just stay afloat, and implementing new technology is sometimes really risky business. Yeah, unless it's truly proven. I mean, from the network engineering point of view is one, from management point of view is another.
Absolutely.
Yeah.
So
these are just the problems which I see.
Sure.
Really. I mean, how do I go to my HR person and say, I'm looking for a person who does SDN? There are some question marks.
Sure. I think it's a really good point. So the thing here is about maturity of the technology and the expertise to be able to enable this. And so one of the key points that we made as part of this tutorial is that SDN is not a revolution, right? I mean, as much as it's hyped up that way by the media, it's not. We adding stuff to existing networks. There's nothing. Revolutions happen when there's a complete sort of forklift, a greenfields kind of environment. We will never have this, right? So this is about adding incremental capability to your network. So add a bit of Openflow if there's an application. Add netconf yang. So it takes some baby steps towards getting there. It's an organic kind of growth of your network into an SDN kind of system. It's not going to be done as a forklift for sure. Jeff.
So you're asking for applications, and throughout my career I've done a lot of backbone networks, and started with IP, moved to ATM, moved to MPLS as a core, right? So putting IP on top of a very stable infrastructure makes it behave much better. If I were doing that again, and I'm working on an actual SDN that has NFV, et cetera, so it's a system that does exactly this. But if I were back in the core business, I would be looking at this technology because it's cheap, it's fast, it's very simple to create Ethernet flows from one side to the other, right, with this technology. And this is what I would be looking at as a core.
Brilliant, yeah. So solve real problems, right? It's not about embracing technology for its sake. And the thing that I think also we have to recognize is that this is both SDN and NFV have not come from the vendor space. So this is not about trying to push new technology. SDN from academia, right? NFV from operators. So there is some real reasoning behind why this exists. anything else? Any other questions? Feel free. This is a great opportunity to hear from everyone else as well.
Yes, sir.
Thank you. Aside from Openflow or OpenDLH project, there are some other competitors in the industry. Cisco is trying with Nexus and ACI, and VMware is implementing his NSX. Those are different from Openflow. So when I am preparing myself for SDN, I have to think which will persist for the long run, whether industry will embrace the Openflow or the proprietary techniques. So what do you think? What is the future of the Openflow? Market capture. What will be the, whether it will capture the whole market or at least 50%? This is a major issue when I am training myself.
Right. Okay. So let me just address the Openflow thing. Right. Openflow is not the solution to SDN, right, as it was thought maybe 5 years ago. So 5 years ago it was about complete separation of control plane, data plane, using Openflow to program the switches. Doesn't really work in practice, right? So no one's really doing that, like using Openflow as a sole mechanism. There's a whole bunch of other protocols that have come about, and what the industry has converged on is a hybrid Sdn model. So hybrid in the sense that pure Sdn was about decoupling the control plane completely out of network devices and having flow tables in there. Hybrid is where you keep some of the control plane functionality on the devices and centralize some of the functionality. So you centralize what makes sense and where you can get some benefit. So like, end-to-end path computation makes sense to be centralized. Things like IGP doesn't really make sense to centralize, so keep it where it is, right? So that's the model we've ended up with. So Openflow is probably not the right thing to talk about here. Openflow is being used for traffic sharing and so on, right? It's being used in some data center contexts. But there's a whole bunch of other protocols that have come about, like we said, netconf yang, PCP, BGP-LS, segment routing, and so on. Those are standard protocols, right? So the advice would always be, if you stay with standard solutions, open solutions, then you're going to be safer in the longer term, for sure. Now, the solutions that you spoke about, the Cisco solution and the VMware solution, they're data center solutions, right? So we need to separate SDN in the data center from SDN in the wide area network. There are different solutions to it. And a lot of the SDN in the data center is about building overlays, right? Taking existing network environments in the data center and building some sort of overlay solution. So some are using proprietary mechanisms, some are using more open mechanisms. So that's a determination you've got to make yourself, right, as to which one you think is a better solution. Now, proprietary solutions will of course not interoperate, right? So that's going to be a factor. So and that's not just for this; it's for everything out there, right? So if you go with a proprietary solution, you're stuck with it. You do not have the leverage of bringing other vendors in. So if you stick to open solutions, you're probably going to be a lot better off in the longer run, right? But evaluate these separately. SDN in the WAN, in the data center, they're quite different, right? I'm not sure if that answers your question.
Okay, thank you.
Okay.
Any questions? Anything else?
It looks like all of you want an early lunch.
Yeah, thank you so much. Then, if there are no further questions, we were just trying to get everything consolidated into one tube, just so that from an awareness point of view, if not anything. So thank you so much for your time. Let's break for lunch then. Yeah, thank you so much.